Thank you, Cameron. Fantastic session. Apologies for the demo ghost there, as one of my good friends would have said halfway through, but really interesting session from Cameron. His first ever presentation at this kind of event, so a particular well done to him this morning. Just before we move on, I just want to ask Simon, as that transition was a bit rushed, if we had any questions through about that scripting environment at all, Simon?
Yeah, we did, Robin. We had a great question around whether it was possible to automate flat patterning.
Okay. So absolutely yes is the answer to that. So thank you for that question. Actually a really valid question. So as I said earlier, within reason, we can kind of do most things that either Inventor or Windows can do. So we could identify that the type of the component is a sheet metal component. And off the back of that, we could get it to A, generate a flat pattern if there isn't one already. B, update it if there is one. And then even go ahead and export the DXF files specifically for that flat pattern before linking them back to the files inside of the Vault. So great question, whoever that one was from. Thank you for that. And absolutely yes. Okay, so on to my fuller session this morning. So you've got me for the next 35 minutes or so. And I want to just talk briefly about building information modeling for manufacturers. And actually during this session I want to dive into a little bit more detail than perhaps what you would have gone through before on this subject, certainly for one of these types of sessions, because I want to talk about some of the standards and some of the requirements that you might be asked for if you are manufacturing building components or components for the AEC industry and being asked for digital construction models. So bear with me, and then at the end of the session I will demonstrate some of the new Inventor 2022 functionality for linking Inventor with Revit more natively. So I guess the first thing to note really is it's probably fair to say that when we think of BIM or digital construction, it can seem like quite a complicated piece of code to decipher. Certainly there's so many different standards and so many people or individuals giving different levels of advice. So it's tough out there. But actually, if you strip it back, the general message behind it isn't all that complicated. It's actually not half as complicated as the backstory of the Matrix, for instance. And actually, if you did a bit of research into the Matrix code, it's a Japanese sushi cookbook. So it's not complicated at all when you strip it back to actually what it's trying to put across. Great film, by the way. So what I want to do is try and do that a little bit for you this morning over the next half an hour or so, and explain what may be required of you. So I'm going to start by talking a little bit about digital handover, because sometimes the easiest way to understand this is actually looking at what it's there to do. So why is digital construction or building information modeling there? You know, what's the point of it all? And actually, if you look at why it exists, we need to start with the end goal in mind. We have these fantastic 3D parametric digital construction models known as digital twins, and they are linked to a series of detailed 2D drawings, elevations, sections, schedules, information takeoffs, reports, and that builds up our building information model. The reason that we have those is so that we can have better interoperability, more modern connectivity, and a better flow of information for the life cycle of that asset. If you can imagine, historically, when a building was completed and handed over, there would be floppy disks, there would be O&M manuals, like this, that would be handed over with that building to the asset owner or the facilities manager. In this day and age, even though we've got USBs and DVDs and things have come a long way since then, and Blu-ray discs, that handover still happens. What we're trying to do is modernize that and make it easier so that that information, if it's digital, can go straight into a facilities management CAFM system. It can go straight into a building management BMS system, for example. And that's the idea of this. That's why this process is kind of being put in place and modernized to make everything a little bit easier. So what does that mean? It's not just all about models, essentially, is the clear point there. The information is sometimes more crucial than the detail within the model itself. And that's something that we're going to touch on as we go through the session this morning. So, for example, a spec sheet that is explaining about that model might be more important and more detailed even than the actual model itself, which could just be an envelope, for example. So, what does that actually mean for us as manufacturers? What do we need to do if we are asked to collaborate with or provide a BIM model as a manufacturer? Well, quite simply, there's a single requirement there, if you will, but it's split into a couple of different parts. So firstly, yes, you will need to produce a graphical or geometrical model. That model we're good with, right? We have Inventor. Other products are available, but Inventor's the best one. And that's there to produce a fantastic fabrication quality model. Nuts, bolts, washers, the lot. So we're good with that. It'd be too much detail for the likes of Revit or ArchiCAD or any other architectural system out there. So we generally simplify it, but we're good with the model. What we struggle with is the information. What information do we need? Because our object, our BIM model, if you like, needs to be both non-graphical and graphical information. Alphanumeric and geometrical information, to give you the official terms. To understand what you need to do to get to that point, I'm going to have to talk through some standards. I'm sorry, I didn't really want to this morning, but we're going to. I'm going to keep this really light and hopefully try and stay chipper throughout. But essentially, there are a load of standards that you will need to align to if you need to work on or collaborate with a building information modeling project. These ones on your screen, namely the ISO 19650 documents now, because the PAS ones are in the process of or already have been withdrawn. For example, parts 1, parts 2, and parts 3 and 5 have already been withdrawn of the PAS documents, replaced with a new international standard, ISO 19650. These ones generally you are only needing to fully appreciate and understand if you're getting more hands-on on a project. So if as a manufacturer you actually get involved with the design, the placement, the installation and the project, then you're going to need to appreciate at least some of these. If you're just manufacturing an air conditioning unit or an air terminal or an electrical distribution board, the likelihood is you model it, you provide the information, you hand it over, job done. In that case, you won't need to appreciate or understand these standards. If I just strip these back for those of you on the call that do need to at least understand what they mean, a lot of people are still throwing around the 1192 terminology. These have been retired now since the launch of the ISO in 2018, December I think, that year. So a number of years now. So we should be using the ISO 19650 standard from here on out. And what we have with the standards in ISO 19650 is part 1 and part 2, which focuses on the core concepts behind digital information modeling, building information modeling, and the workflow, alongside how we deliver to a project and a naming annex which is UK specific to make sure we name files correctly. That's bundled with a guidance document, part 0, which explains how to transition from the PAS documents to the ISO. For most of you, that will be pretty irrelevant, but it's worth understanding that these documents are there to support the entire life cycle. So in ISO 19650 Part 1, we have this transitional life cycle of an asset, starting at its concept, going through all the different data sharing points, REBA stages, data drops, and collaboration points along the bottom before it goes up the side there, back round to the start. So this really is a life cycle process that goes around and around for the entire life of that asset, whether that asset is a building, a renovation, a floor, an individual component. It's a life cycle that follows something around. Think about that end goal, where we're wanting to be. So we have to follow that round as a life cycle. The standards that are going to be more important from your perspective, and probably for 95, if not more percent of people on the call, are some of these. So generally as manufacturers, we need to provide content, or we like to provide content, as I said earlier. So the key ones really here, for me, there are two. or there are two families or suites of standards. Firstly, the BS 8541. That explains how you should be naming and modeling your components for use in a digital construction world. We'll talk about those in a second. You then have ISO 16739, which talks about the industry foundation class. The only reason I flag that one is because Inventor, for the past few years, has been able to export IFC files, industry foundation class. If you're being asked to produce IFC files on a project and you're collaborating, you need to read and understand that standard because it will explain how you should be using that IFC and it will help you being compliant against that project. If we take a few seconds just to talk about the 8541 series, as they're typically the most important ones, just to note it's being replaced with an ISO, no release date yet, but just keep that in mind. We generally have a few different parts, and I'm only going to talk about a few of these. Part 1 is for naming. So in BS 8541 Part 1, it focuses on how we name components. If you're supplying a BIM object to one of your clients, you need to name that object aligning to this document, full stop, the end. That's what you need to be doing, unless it's specified otherwise within your contractual documentation. It's pretty straightforward. You have a source, which could be MAM for man and machine, for example, could be ADS for Autodesk, for example, followed by a delimiter, followed by a type. In this example, we have a light fixture. We might have a HVAC unit, for example. And then we have a subtype, which is a more optional field, but it's a better description of what that component is. And this standard goes to the nth degree, some fantastic bedtime reading if you've got some insomnia. It goes to the nth degree on explaining that naming standard and how you should name different types of components. If you're needing to get involved and create these objects, they need to align to that 8541 Part 1 naming convention. Part 2, not for everyone this one, but certainly worth flagging because I'm sure we've got a number of people on the call that are producing or manufacturing electrical equipment or equipment that touches MEP, mechanical, electrical, plumbing designs. Whether this is an attenuator for a ducting system, whether it's an electrical distribution board or a plug socket or something like that. Move out of the way, that last one. You might need to put symbology on there so that inside of Revit, for example, as well as a 3D object, you have the correct symbology to show that particular component on a floor plan correctly from a standards perspective. So if you do one of those products, you also need to understand that standard. Part 3, I'm just going to focus myself there, not because I want a close-up on my face, but because I want to try and get it focused properly. There we go. Apologies for that. Magic. So part 3 of BS 8541 is all about shapes. This is the single most important one for you because it's talking about how you should be developing your components. It talks about different styles of component, different uses of component through concept for a schematic level of detail. So look at the chair example here. It's very boxy. Through to visualization, very detailed and containing all of the if, buts and maybes. That's hugely important for us in manufacturing. As I said earlier, modeling is second to none. We contain we produce some great quality models, and I'm always flabbergasted to see some of the models that our customers and you guys are creating. They're fantastically detailed and, to be fair, awesome. But we have to strip those down. So it's important to understand how much by and reading and appreciating this standard to do that. You then have information attached. So part 4 of the 8541 series talks about what information you need to put against it to tick that box about the information. This is one small piece of a bigger jigsaw puzzle, for example, with information. But again, it's important to read and understand. I'm going to skim over the last ones, part 5 and 6, very quickly because they're more specific. Modular building design, assembly design, not assemblies as in IAM, Inventor Assembly, but as a group of components nested together. We don't typically need to worry about that too much. And part 6 is mainly about how we exchange stuff and what it's going to be used for. Again, don't worry too much about those. There are a load more that, quite frankly, you don't need to concern yourselves about unless you're hands-on on a project. Okay, so don't worry about them. Maybe with the exception of the Uniclass format. Uniclass is there as a classification system that you will need to tag into your products, but you don't need to read this inside and out to the nth degree. It just means that against your Inventor assembly or part, for example, you'll need to have a code and a description that explains exactly what that component is. Doesn't matter whether that component is an envelope shape or a detailed model, it explains exactly what that component's all about. Whew, standards. If you need them, then they're the ones that you're going to have to read and appreciate. But actually, there's stuff in there that you won't necessarily need dependent on your involvement. So, going back to our manufacturer standpoint, great, there's some standards. What do I need to do? What does that mean for me? How do I take that information that you've just thrown at me in the past 15 minutes and actually appreciate it and understand it? So if we go back to this initial requirement of your model and your information, again, if I use the official terminology, alphanumeric, non-geometrical information and geometrical information, we have a model and some information. What do I need to do to produce that? How do I go about doing it? You keep talking about information. What's this level of information and why do I need it? And how do I define what that is for my particular product? Again, we talk about complications. There's so many different if, buts and maybes and level of detail, level of development, level of definition, level of geometry. There's almost too much there, and it's very easy to get confused and overloaded with different methodology. The ISO standards have made this so much easier for everyone, including us as manufacturers, in that what we have nowadays is what we call a level of information need. Now, what that means is everything's driven from the top down. The client, that means the actual client on the project for the building, define what information they need. In other words, they're taking this data into a CAFM system or into a BMS system. So they will know what attributes and metadata that those systems need and how detailed they'll need their geometry. So the idea of the level of information need is that they define what information they need. It's not called level of definition, level of detail, level of information anymore. It's level of information need. And they're defined by the standards suites of documents. Again, if you wanted some more bedtime reading, there's another one for you. It's every time I duck. Do my magic trick again. Just get the focus back on. There we go. I feel like Houdini. So what we have with that is a load of specific questions. So, okay, why is that information there? Why do we need that information? When do we need that information by? Because providing 100 properties at the start of the project is a waste of time, pointless. Providing them at the end is very useful. And it's about staging the right information at the right time. Again, from our side as manufacturers, it's probably bundle everything in. But if you're more hands-on on a project, it's identifying when you will need what within those delivery milestones. And again, we've then got those geometrical informations, those alphanumeric information, and the documentation that ties all of this together. It's a lot easier to understand within the ISOs. And if we just look at the actual rules here, for a building and an actual component as well, we have 3 very different levels of design: concept, options appraisal, and detailed design. You can see both in the building at the top and in the model at the bottom there that you have 3 very different styles. They align very much to what you saw on the 8541 Part 3 standard earlier. We have something that is fit for purpose when it's needed at different points throughout the design. That's all very well documented by the National Building Service, the NBS. So check out the NBS definitions library, type in and do a search for the type of component that you produce and that you manufacture. And what it will do is it will list a number of bits of information on there. Firstly, it will list the different detail levels that I've just explained and the kind of model look and feel and 2D look and feel that you would need for each one of those. Against that, you can dive into the information and see what levels of information you would need against those particular ones. And it basically lists attributes and descriptions as to what they should contain. And again, as manufacturers, It's quite simple for us because we've got all the data for the most part. We've got all of the information, so it's just a case of loading it all in, to be quite frank, in Inventor as an iProperty, for example, against the parts or the components. Our process in manufacturing will only get easier because more and more companies are looking at these product data templates. And what these do is they purely focus on information. Again, as manufacturers, we need to load everything in. So the way that this is going is we have a model and then we have a product data template. That product data template will contain reams and reams of properties against the component for different standards. So there might be one for the IFC standard, there might be one for Kobe standard, there might be one for Uniclass, there might be one for the ISO standards. The list goes on. But the idea is the people using your components pick the ones that they want and then they use them. So there's so much information here. It's a lot to take in a short period of time. But again, it's just a case of going through and appreciating what you're needed to do. So models and information. And then with those two different types of component, you have one handover as such. Okay, so let's just skip that next one. So getting back to the point, I guess. So great. How do I go about doing that? So I've got Inventor. I've got a great model in Inventor. What do I actually need to do to get a bit more hands-on? And how can I really progress myself? And what I've tried to do this morning, without just throwing a load of stuff at you, which has been gone through quite quickly, is show you that there are people here that have a lot of information in here, which we want to share with you. And these slides that I've been presenting through so far this morning, they've been put together by some colleagues that are far more handsome and intelligent than myself in our digital construction team. For our BIM Ready training courses, both BIM Ready Fundamentals and BIM Ready for Project and Construction Professionals, as well as an upcoming course which is being regenerated, aligning to these new standards, BIM for product manufacturers. So we've got a lot of wealth that we're ready and wanting to share, because there are standards naturally that you're going to need to understand. If you don't know which ones you need, please reach out to us because we can help you, we can point you in the right direction. There are a number of processes that you need to appreciate, whether that's processes internally or even processes once you've handed over your data. Because for me, if I was doing it, I would want to know what my data is being used for so that I can leverage that, understand that, and make sure that my data is aligning to that to put me best in class. Again, if you don't know what that is, reach out, approach us, we're ready to help. Leveraging technology for me is an important one. For those of you that have met me, you will know that I'm a self-confessed geek. For those of you that haven't met me, I am a self-confessed geek. So it's all about the technology for me. The standards bore me to death, but you've got to understand them and appreciate them. But if there's a way that I can leverage technology to show you how to make your life easier, to speed up a process, much like Cameron did this morning, and much like some of the stuff that Chris is going to show shortly, like model states, it's hugely time consuming to not use those. So why wouldn't you? Know your project role in a project. Know how much you have to and how much you don't have to do. Appreciate that, and that will help you on your process. And again, please approach us because we've got a lot of knowledge and we've got a lot of ability to help you. So this leverage technology bit, I guess the sexy part of my presentation, the bit that you probably all want to see and get me to stop talking about standards. I'm going to focus on one specific area, but before I do that, I kind of want to do a throwback to what we did last year in October and earlier this year for our virtual summit events, where we focused on the BIM content creation tools inside of Inventor. Those sessions are live on our website, they're live on YouTube, and you can go and rewatch them now to appreciate how to create Revit families, for example, from Inventor, to include both geometry and metadata to get that requirement sussed essentially. So revisit those, look at those, and approach us if you need more help, because we can even automate that process using, you guessed it, Vulcan Cool Orange, should you need to, with a little bit of help from iLogic. But what I want to focus today on is the new functionality in Inventor 2022, which is really pushing better collaboration between Inventor and Revit, between the manufacturers and the architectural engineers or the structural engineers or the MEP engineers that are using those products. Autodesk has done a fantastic job this year of focusing on just that, collaboration. Forget about BIM for a second and focus on using Revit data in Inventor and then using Inventor data in Revit more natively, more naturally, and without having to use an in-between format like IFC, for example, which we can still do, by the way. So what I want to show you for the remaining 10 minutes or so of my session is this new feature in 2022. Because for me, it's introducing fuller Revit collaboration. Because we can now create Revit project files, RVT, directly from Inventor using the Simplify tool in 2022. Naturally, it's 2022, so those Revit files will be Revit 2022 files. That's very important. If you need to know why, come and speak to us, but it will depend on the project or the version of Revit that the project is using. It's only focused on geometry for now. I've been told by a good source that metadata is coming sooner rather than later, so watch this space. But it's focusing on geometry. So again, for me, it's a great one to show this morning. I've told you a little bit about the standards and the information, but now let's jump into Inventor and look at some cool stuff. So let me just jump to my desktop and open up Inventor, like so. And I'm just going to use, it's a bit Blue Peter style essentially, but I'm going to grab a data set that's already been put together for us. By our colleague and friend Paul Mumford, and I'm just going to open up this data set and run through it with you step by step, and it will really help you get the process nailed. So what I'm going to do is just firstly start inside of Revit actually, because sometimes it's good to see and appreciate what we're working with. Some of you may not have seen Revit before, some of you might be new to it, some of you might be very familiar. So I'm just going to open up this Revit project RVT file inside of Revit 2022 and essentially show you what we've got. So let's go to a standard 3D view and show you that we've got, you know, a pretty generic building. We can look inside this building and see that we've got a load of steel, a load of lighting, some architectural elements and some HVAC. And what I want to do in Inventor is design an assembly line bay in here using the power and the tools within an Inventor. So I want to have a crane there, and I want to have some different bits and pieces and some components, and use maybe some of Inventor's factory design utilities to get that production bay put together. I'm not going to do all that today, I'm going to just turn it on. But it gives you an appreciation of what we're doing. So inside of Revit, I've created a simplified view. That view strips out the stuff that as a manufacturer I just don't need. And then in Inventor, I'm going to go into my assembly and place an imported CAD file. I'm going to identify that I can come in and choose Revit RVT files. And I'm going to choose that same RVT file that I've just opened inside of Revit. This gives you two options. You can reference the model, which I would recommend, or you can convert the model, which I wouldn't recommend. Converting will literally try and convert the geometry to Inventor geometry. It's a one-time thing. It's great if you're a fabricator that actually manufactures fabricated ducts, because we can import a Revit file full of ducts and convert them to Inventor geometry, say it's sheet metal, rip it down the middle and open it up and get a flat pattern. Happy days. But actually, for what I'm showing today, it's a reference model that you want. So we choose reference. I'm going to use that same view from Revit just to make my life easier, which was called Production B Coordination. We could filter on components if we want to. So if we want to say don't import this type of component, do import these types of components, we can. I've got a pretty high spec machine here, so I'm just going to say OK. Inventor will warn me that it's about to import nearly 700 components. Again, I've got a high spec machine, so I'm not too concerned. But if you're running a lower spec machine, this might be a hit OK, go and make a coffee moment, or you just filter down the ones that you do not need to work with. So we've got a few issues with our library, so let's just say we're not fussed about this for the purpose of today's session. And what you'll see in a few seconds is that same Revit model will appear inside of Inventor. And actually it will look really nice. It will look pretty much the same as it does with inside of the Revit interface. And it will work just like a standard component. So it will stick the component onto my mouse and it will allow me to place it. When it does so, I'm going to tell it to place it grounded at origin. Just wait for it to think about life. Hopefully the demo ghost won't strike 2 times in one session. Let's hope not. There we go. I'm going to place it grounded at origin to make a relationship between Inventor 00 and Revit's coordination point. And what we're going to do now is just go and look at our representations and grab the camera from that representation. And I think Revit had the perspective mode. So there is our view inside of Inventor. From now, I'm just going to go and turn on the components that are already modeled, to be quite frank. So here are my Inventor components that I would have modeled and constrained around this. And what we can see is if we just drive this constraint here, is we've got an issue between the crane and this piece of HVAC. Now I could use Inventor to model that and move it, but actually let's imagine that the placement of this crane is it has to go there for some reason. Maybe there's specific reinforcements or a specific reason that it has to go there. So we're going to be cheeky and make it the Revit user's job to update their model. So all I'm going to do is save my assembly. Because I'm going to push this into Revit, I want to turn off the visibility of the Revit model, because otherwise we'd have 2 components over the top of each other, which would be not worthwhile. So once this is saved, I'm just going to use a standard right-click visibility option over the RVT, which you can see is linked on the left-hand side over here. Apologies, this is a little bit slow. It's obviously struggling a little bit with all the stuff that we're running on this machine. It will get there in a second with it saving. And then we will create an RVT using Inventor's new Simplify tool in 2022. Now, while this is still thinking about life, Simplify in Inventor 2022 is going to give you a lot more flexibility to simplify your product down to simple shapes, envelopes, remove smaller components, fill voids, so on and so forth. And I'm not going to show it in this session in a huge amount of detail because my colleague Chris is going to cover it off in more detail than me afterwards. But that tool has been leveraged to push the RVT export functionality inside of Inventor. So what we can do as part of that simplification process is say, okay, I want to send this data out as an RVT file. Based on that data going out, I either want to simplify it, and that might be saying define envelopes on there. It might even be saying, I don't want envelope shapes. I've already got a shape modeled based on BS 8541 that I want to convert to using a model state. Again, Chris will show you some of that in a bit more detail shortly. I'm a bit concerned that this is giving me the spinning wheel of death. So what I'm going to do is open up another instance of Inventor 2022 from my desktop. Typically, once I do that, I bet it will just sort itself out straight away. No, it won't. And we'll just open it up from that point and continue. So apologies for that, the joys of live demos. And we'll just go straight in and start the simplify command. Just check that's not caught up yet. No, it hasn't. It's locked. Okay, so let's say don't show. So we'll start off the simplify command and we'll just show you some of the tools. Again, Chris is going to show this in a lot more detail in 5 minutes or so. So what we'll do is load it up. This is what I get for talking about standards, you see. Talk about standards. Inventor doesn't want to know. Doesn't like BIM. Here we go. Okay, so I'm not going to save it this time. I'm going to turn off the visibility of the Revit model, and I'm just going to start the simplification tool up here. Now, at the moment, there's far too much detail in here for Revit. If you look at the cages down here, we've got people, and we've got very excited people with their hand over in the air because they're manufacturing. They're not doing BIM, so they're excited. What we're going to do is use model states to simplify this. But before we do so, I just want to show you that what we can do is tell Inventor to replace objects with envelopes. I'm hoping this is going to work based on the crash that we just had. Yeah, it's fine. So we can replace the whole thing as an envelope. We can replace each top level component as an envelope, or indeed each individual part. So it will literally just turn them into the envelope box shapes or cuboid shapes or spherical shapes that you can see on the screen, which is really useful if you're being lazy or if you want to do something quite quickly. Again, If we followed 8541, as I said earlier, we will already have these modeled, and leveraging the model states inside of Inventor nowadays is great, because I can literally say, use my medium level of detail model state. And what this will do, he says, wondering why it hasn't done it, is it will go in and it will update to have nothing. Okay, last chance to loon Inventor, otherwise model state, there we go. Model state seems to have got stuck for some reason. I won't go through the export, we're a bit pushed for time, so apologies for that. So on the simplify, we would come down here and we would choose to export to Revit. Again, this will create Revit 2022. We define a name, we give it a location, and then we choose whether or not we want a single element, one lump, or whether or not we want to have each as an individual component. For the purpose of this, we want each individually. We'd choose on some advanced projects to say, properties say that we want to fill voids and stuff like that, and we'd hit OK. Luckily, I've got one that I created earlier, so I'm just going to close down Inventor and go into Revit and say that I want to insert a Revit link. And from that Revit link, I'm going to grab this export here. So this export is the Inventor RVT file that's been created. I'm going to say that's opened into Revit, and this will create a link. It's a bit like an XREF. You'll know XREFs because you're using AutoCAD. And I'm going to jump into my main view here, and what we'll see is we now have that crane and the production facility without all of the holes and components that we didn't need inside of here. But clearly we've still got this clash. So I'm going to select this duct, jump onto my ground floor pan, and I'm just going to make a very small amendment. So with this duct, I'm just going to say that that's maybe 3 meters away from central beam rather than 5. I'm just going to press save on Revit. And what I'm going to do is jump back into Inventor, and all being well, what Inventor will do is it will identify that we have an update, or not, as the case may be, because the demo gross has well and truly got me. So what would happen is you would get prompted for an update. At that point, maybe it's done it already. At that point, it would update the Revit file, and that Revit file would then just be brought into Inventor. In this case, maybe it was just too quick for me. We can see that this file has been updated so that I no longer have the clash. So if I go ahead and drive that that constraint that we had earlier, there we go, rotation, right click, drive, and play that, we can see that we have now no clashes between the crane and the MEP system. Last thing is that everything that you do is linked. So that simplify that we created earlier, up here at the top, you'll notice that we have a Revit export link. So at any point I can update that to re-export the RVT. I can edit the simplify that was used to create that to go and change any of those settings, and it becomes embedded as a link at that point, which we can then work with. For me, this makes collaboration between Inventor and Revit so much easier and so much nicer to handle. So that's kind of all I wanted to show. Apologies that we had a few glitches there in the matrix. But let's just jump back for my last slide. So, okay, hopefully some of that's been useful. Clearly there was a lot of information to cover in a short period of time. We had a couple of issues, so apologies for that, and sorry to Chris for overrunning a little bit. But just to leave you on a point that Simon made earlier, our BIM for product manufacturers course that we're re-releasing after the updates to all of the different standards is nearly ready. But what we're really keen to hear is your feedback. This course will cover principles of BIM and digital construction, including how you implement it within your business and what different workflows contractually you might need to go through. It goes through in detail the different standards that you'll need to work on, including 19650 Part 1 and Part 2, and including 8541, as well as Uniclass and the other ones as well. There's a deep dive into the level of information need, focusing on what information you need to provide, why, and how you go about understanding what you need to provide within the manufacturer's data. We'll also throw in there a hands-on workshop where you can use Inventor, where you can leverage technology and understand and appreciate what you can do to fill in those voids. We feel that this course is going to be fantastic for the product manufacturers and leveraging the best of BIM with the best of manufacturing. We've got the right skills internally to deliver it, and we're really looking forward to being able to bring this to you later in the year. Anyone that's interested in this course, struggling on anything specific that they would think would benefit to be in this course, please reach out. But without further ado, I'm going to be quiet and hand over to Chris, who's going to take us through from some what's new in Inventor 2022. So we'll just put a break video on for a minute or two just while we switch over, throw this machine out the window and get a different one, and we'll carry on.